Download this code from codegive.com, link in the description below. OK, let's dive into deploying cloud-based security solutions, focusing on SASE, Secure Access Service Edge, and SSE, Security Service Edge, with practical code examples where applicable. This will be a comprehensive guide covering the concepts, architectures, implementation steps, and potential challenges. Understanding SASE and SSE. Before we get into deployment, it's crucial to have a solid understanding of what SASE and SSE are and why they are important. SASE, Secure Access Service Edge. Gartner defined SASE as a framework that converges network and security functions into a single, cloud-delivered service. Think of it as a unified platform that delivers both network connectivity and security to users and devices, regardless of their location. SASE aims to overcome the limitations of traditional network and security architectures that struggle to support the distributed workforce and the rise of cloud applications. Key components of SASE. SD-WAN, software-defined WAN optimizes network connectivity across multiple locations and internet connections, providing intelligent traffic routing, bandwidth management, and resilience. Secure Web Gateway, SWG filters web traffic, blocks malicious websites, and enforces web usage policies. Cloud Access Security Broker, CASB provides visibility and control over cloud application usage, preventing data breaches and ensuring compliance. Firewall as a Service, FYS, a cloud-delivered firewall that protects against network threats without requiring on-premises hardware. Zero Trust Network Access, ZTNA grants access to applications and data based on identity and context, rather than network location, reducing the attack surface. Benefits of SASE. Improved security posture. Simplified IT management. Enhanced user experience. Reduced costs. Increased agility. SSE, Security Service Edge. SSE is essentially the security component of SASE. It's a subset of SASE that focuses specifically on security services delivered from the cloud. If SASE is the complete package, SSE is the security building block. Key components of SSE. Secure Web Gateway, SWG. Cloud Access Security Broker, CASB. Zero Trust Network Access, ZTNA. Relationship between SASE and SSE. SSE is the security part of SASE. SASE includes both network and security functions, while SSE focuses solely on the security aspects. You can think of SSE as a standalone security solution, whereas SASE integrates network optimization with that security. Organizations may choose to deploy SSE first and then later add SD-WAN components to create a full SASE architecture. 2. Deployment strategies and considerations. Deploying SASE or SSE is a strategic undertaking. Here are some key considerations. 1. Define your requirements. This is critical. What are your organization's security challenges, example data breaches, malware infections, unauthorized cloud application usage, compliance issues? What are your network performance pain points, example slow application performance, unreliable connectivity, high bandwidth costs? Who are your users, and where are they located, example remote workers, branch offices, mobile users? What are your compliance requirements, example GDPR, HIPAA, PCI DSS? What is your budget? To choose a deployment model *SASE/SSE can be deployed in a few different ways. Cloud native SASE/SSE fully leverages cloud-based services provided by a single vendor or a tightly integrated ecosystem of vendors. This offers the most flexibility and scalability but requires careful vendor selection. Hybrid SASE/SSE combines cloud-delivered security services with on-premises security appliances. This approach might be suitable for organizations with existing security investments or specific compliance requirements that necessitate on-premises controls. It can be more complex to manage. Phased rollout start with a specific use case or a subset of users and gradually expand the deployment. This allows you to test the solution, refine your configuration, and minimize disruption. A common approach is to deploy SSE first, followed by SD-WAN to enable full SASE functionality. 3. Vendor selection * choosing the right vendor is vital. Evaluate vendor capabilities * do they offer all the required components, SD-WAN, SWG, CASB, FYS, ZTNA. Assess their cloud infrastructure * do they have a global network of points of presence, POPs, to ensure low latency and high availability. Check their security certifications and compliance * do they meet industry standards and regulatory requirements. Consider their pricing model * is it based on usage, number of users, or bandwidth. Read reviews and case studies * what do other customers say about their experience with the vendor? 4. Integration with existing infrastructure * SASE/SSE must integrate seamlessly with your existing network and security infrastructure. Identity management * integrate with your existing identity provider, example Azure AD, Okta, Google Workspace, for user authentication and authorization. This is absolutely essential for ZTNA. Security information and event management, SIEM integrate with your SIEM system to collect and analyze security logs and events. Endpoint security * integrate with your endpoint security solution, example antivirus, endpoint detection and response, for comprehensive threat protection. 5. Network design * plan your network architecture carefully. Traffic routing * configure SD-WAN to intelligently route traffic based on application, user, and location. Bandwidth allocation * allocate sufficient bandwidth to support the increased traffic from cloud-based services. Quality of service, QoS prioritize critical applications to ensure optimal performance. 6. Policy configuration * define clear and consistent security policies. Web filtering * block access to malicious websites and enforce acceptable use policies. Cloud application control * control access to cloud applications and prevent data leakage. Data loss prevention, DLP prevents sensitive data from leaving the organization. Firewall rules * define firewall rules to control network traffic and prevent unauthorized access. 7. Monitoring and reporting * implement robust monitoring and reporting capabilities. Security dashboards * monitor key security metrics and identify potential threats. Alerting * configure alerts to notify you of suspicious activity. Reporting * generate reports to track security performance and compliance. 8. Training and support * ensure that your IT staff is properly trained to manage and support the SASE/SSE solution. Vendor training * take advantage of training resources provided by the vendor. Documentation * review the vendor's documentation thoroughly. Support * establish a clear process for contacting the vendor's support team. 3. Practical code examples, conceptual. Because SASE/SSE solutions are typically delivered as a service, direct code examples are limited. You'll primarily interact with these services through APIs, configuration consoles, GUIs, or infrastructure as code, IAC, tools like Terraform or CloudFormation. Let's explore examples of how you might interact with some of the components through code. A. CASB API interaction, Python. This example shows how you might use a Python script to interact with a CASB API to retrieve a list of sanctioned cloud applications. This is a conceptual example. The specific API calls will vary depending on your chosen CASB vendor. Explanation *. 1. Import libraries * requests for making HTTP requests and JSON for handling JSON data. 2. API endpoint and key * replace placeholders with your actual API endpoint and API key. Never hardcode sensitive information like API keys directly into your code. Use environment variables or a secure configuration management system. 3. Headers * sets the authorization header with your API key, typically using a bearer token, and the content type to application/JSON. 4. Make the request * uses requests.get to send a GET request to the API endpoint. 5. Error handling * response.raise _ status checks for HTTP errors, example 404 not found, 500 internal server error. 6. Parse the JSON * response.json, parses the JSON response from the API. 7. Filter for sanctioned apps * the code filters the list of applications to only include those with a status of sanctioned. 8. Print results * prints the names of the sanctioned applications. 9. Exception handling * includes try, except blocks to handle potential errors like network issues, invalid JSON, and other exceptions. B. Terraform for FYIS deployment, example. This is a simplified, conceptual Terraform configuration that demonstrates how you might use Terraform to deploy a firewall as a service, FYIS, resource. The specific resource names and attributes will depend on the FYIS vendor you're using. Explanation *. 1. Terraform block * specifies the required providers. You'll need to replace FWAS provider with the actual provider name for your FYIS vendor and potentially download the provider plugin. 2. Provider block * configures the provider with your API key and region. Again, store the API key securely using environment variables or Terraform secret management features. 3. FWAS provider _ firewall resource * defines a firewall resource. Name, the name of the firewall. Description, a description of the firewall. Location, the region where the firewall will be deployed. Rule, defines firewall rules. Each rule specifies the source IP, destination IP, protocol, port, and action, allow or deny. 4. Apply the configuration * to deploy the firewall. You would run Terraform init, Terraform plan, and Terraform apply in the directory containing this configuration file. C. Configuration management, Ansible, conceptual example. Let's say you want to use Ansible to automate the configuration of ZTNA policies. This is highly dependent on the specific ZTNA vendor. This is just a conceptual example. Explanation *. 1. Playbook * defines the steps to be executed. 2. Hosts * specifies the target host, in this case, localhost, meaning the script will run from the Ansible host. 3. Tasks * a list of tasks to be performed. Forstna_API_module *. This is a placeholder for a module that would interact with the ZTNA vendor's API. You would either use a module provided by the vendor or create your own custom module. The module would handle the API calls to create, update, or delete ZTNA rules. 5 parameters *. The module parameters, example API_endpoint, API_key, rule_name, user_group, application, action, would be passed to the API to configure the ZTNA policy. Important notes on code examples *. Vendor-specific APIs *. The API calls, resource names, and parameters will vary significantly depending on the specific SASE/SSE vendor you're using. You will need to consult the vendor's documentation for detailed information. Authentication * securely store and manage API keys and other credentials. Do not hard-code them directly into your scripts or configuration files. Use environment variables, secret management systems, example HashiCorp Vault or Terraform secret management features. Error handling * implement robust error handling in your code to catch exceptions and handle errors gracefully. Idempotency * design your code to be idempotent, meaning that running the same code multiple times will have the same result. This is important for automation and ensuring consistency. Testing * thoroughly test your code and configurations before deploying them to production. Infrastructure as code, IAC tools like Terraform, CloudFormation, and Ansible are essential for automating the deployment and configuration of SASE/SSE solutions. They allow you to define your infrastructure as code, which makes it easier to manage, version control, and replicate. 4. Challenges and best practices. Complexity * SASE/SSE deployments can be complex, especially for large organizations with diverse network and security requirements. Vendor lock-in * choosing a single SASE/SSE vendor can lead to vendor lock-in. Consider a multi-vendor approach if you want more flexibility, but be aware that this will increase complexity. Integration challenges * integrating SASE/SSE with existing infrastructure can be challenging. Plan the integration carefully and test it thoroughly. Performance impact * SASE/SSE solutions can potentially impact network performance if not properly configured. Optimize your network design and traffic routing to minimize latency. Skills gap * managing SASE/SSE solutions requires specialized skills. Invest in training for your IT staff or consider outsourcing to a managed security service provider, MSSP. Data residency and compliance * ensure that your SASE/SSE solution meets your data residency and compliance requirements. Best practices * start small * begin with a pilot deployment to test the solution and refine your configuration. Prioritize security * focus on improving your security posture and protecting your organization from threats. Optimize for user experience * ensure that the SASE/SSE solution does not negatively impact the user experience. Automate everything * use IAC tools and automation to simplify deployment and management. Monitor and report * implement robust monitoring and reporting capabilities to track security performance and compliance. Stay updated * keep your SASE/SSE solution up to date with the latest security patches and features. Continuous improvement * continuously evaluate your SASE/SSE deployment and make adjustments as needed. Conclusion. Deploying SASE/SSE is a significant investment that can provide substantial benefits in terms of security, performance, and agility. By carefully planning your deployment, choosing the right vendor, and following best practices, you can successfully implement a SASE/SSE solution that meets your organization's needs. Remember to prioritize security, optimize for user experience, and automate everything to simplify deployment and management. Always refer to the specific documentation and APIs of the SASE/SSE vendors you are using. Good luck.